Hello, Legacy Sabers. Marsh here. So today we're going to talk function compositions. What you want to have on you are your notes, so the foldable, calculator, just to do some like simple addition, subtraction, that kind of stuff, and then a pen or a pencil for this task. The essential question for today, so this is, how do I know that I know what I'm doing after I finish this video? If you can answer this question, then you are A-okay. How do you substitute an entire function into another function? That is what we are accomplishing today. So, function operations. You've done these before. Bear with me. So to perform any kind of function operation using functions, you substitute the function rule for the function name, and then you plainly simplify. So as you can see on our problem here, let me change my color. We have a function name right here. It's f of x, and his rule, or his value, is negative 2x. So whenever I see f of x, I know that his value is negative 2x. G of x is another function name, and his rule is 3x plus 1. Now, if I say f of x plus g of x, what I can honestly do is I can take f's value, take g's value, and substitute. So f of x, they told me, is negative 2x. So I put negative 2x right there, where f of x was, and then I put 3x plus 1 where g of x is. Now, I need to add those two together. So I'm going to combine some like terms. I know negative 2x and 3x are like terms. Negative 2x plus 3x is x, and then I just have that plus 1 hanging out. So f of x plus g of x is equal to x plus 1 is my answer for that addition. A function composition now is when we take a function and plug it in for the x value of another function. So a function composition is a function made up of one or more functions. To find a composite functions, we will always evaluate the inside function first. So they tell us f of x negative 2x, g of x is 3x plus 1, just like last time. They want us to find f of g of x. So that's how that's written. Let me tell you again how to read that. F of g of x. That is that right there. I know, kind of difficult, so that's why I wanted to make sure you understood how to hear that, because I'm going to be saying that quite a bit in this video, and I want to make sure you know how to read that. So now, here's what I do first. I take g of x's value, and I'm going to place it inside those parentheses. So I'm going to put 3x plus 1 inside. So now I have f of 3x plus 1, because that's ultimately what it is, right? Now it doesn't look as scary. What it is telling me now is it's saying, hey, when you see an x in f, can you just plug in 3x plus 1 instead? So I'm going to start writing f's rule, which is negative 2x. I'm going to write negative 2, and then I see an x in my f. But instead of the x, I'm going to write 3x plus 1, because that's what they told me to substitute in for x. And then I just simplify, distribute that negative 2, and I get negative 6x minus 2. Function compositions do take a hot minute to understand. So don't worry if you're still kind of like, huh, what's that? I don't understand. I got you. We'll keep going. But first, let's back up. Let's try a very simple function composition. They want me to plug in negative 2 into the function h. So what I'm going to do is I'm going to substitute a negative 2 into my function h every time I see an x. So I'm going to start writing h. Whoop, I see an x. So I got to put negative 2 in there. Keep writing h. Oh, another x. So I'm going to put negative 2 there. Okay. Now, I need to do some evaluation, some simplifying, right? Let's square negative 2 first. Negative 2 times negative 2 is 4. So that would be 16 plus 4, right? 4 times 4, negative 2 times a negative 2, caused a positive 4. So I'll get an answer of 20. Show my equal signs. There we go. So h of negative 2 is 20. Notice, all I did is I saw an x, I plugged negative 2 in. I substituted that negative 2. You're doing the same thing on example 2, but it's a function, not an actual number. So first thing I'm going to do is I'm going to substitute what g of x is. So I'm going to write the outside function, j, and I'm going to go look up here. G of x's rule is x squared plus 4x minus 3. So I'm going to write that in the parentheses instead of his name. That way it doesn't look as scary and it's a little easier for me to understand. So now I am told that into j, function j, I am going to substitute x squared plus 4x minus 3. So I'm going to look over here and I'm going to write j's function. When I start writing j's function, I'm going to change color here. Every time I see an x, I'm going to write g's value. I'm going to write x squared plus 4x minus 3. So first thing I notice, there's an x. So let's write g's rule. Okay? So that is g right there. But I got to finish writing j because they said plug this in to j. So I have to have j. So I got to subtract 5. Now notice, this right here basically looks like j, but with g instead of the x. Now, let's do some simplification. This looks like it could come out of the parentheses. And then it looks like I just have to combine some numbers. Like that. So, j of g of x is x squared plus 4x minus 8. Let's try another one. G of f of x. So again, what I'm going to do is I'm going to find what is f of x. So I'm going to go g of negative 2x. Just like that. And what I'm going to do now is I'm going to start writing g's function. But when I see an x, I'm going to put a negative 2x instead because that's what they're telling me to do. They're saying plug in negative 2x in for my x. So first thing I see on g, I got to plug a negative 2. But note, or an x, I got to plug into that. But notice it's a squared. So what I'm going to do is I'm going to write that information has to be squared. Then I'm going to go change my function here. They said negative 2x is what we're substituting in. Okay, now I gotta keep writing my g. So I'm gonna go plus 4, another x. So I'm going to show that I'm gonna plug in to my x a negative 2x, because that's what they told me to substitute in. And I gotta finish my g. Now see how the outside function g is still present right now. I haven't completely gotten rid of it. I just substituted in for the x. Now, let us simplify. Negative 2x squared. Remember, okay, little sidebar conversation here. Negative 2x squared is the same as negative 2x times negative 2x. Well, negative 2 times negative 2 is 4. X times x is x squared, right? So this guy over here is 4x squared. That's what this simplifies down to. 4 times negative 2 is negative 8x. And then I have that minus 3 hanging along. That seems to be the final answer for g of f of x. Let's try example 4 now. So f of h of x minus g of x. Oof. Now, notice how this is a composition and it has a function operation with it. Now, take it from me. Do not try to do both of these at the same exact time. Do not do the composition as well as subtract. May I recommend to do the composition, figure that work out, get the actual answer to that, and then subtract the g of x. So here's what Marcia's going to do. She's going to figure out what f of h of x is. So f of 4x squared minus 2x, right? I need to plug in 4x squared minus 2x into f wherever I see an x. So I'm going to say negative 2, then 4x squared minus 2x. Distribute that negative 2 in. And I get negative 8x squared plus 4x. Now, that is f of h of x. I am not done with this problem yet because I still need to take that and subtract g of x. So I'm going to write out that negative 8x squared plus 4x is the composition. Then I'm going to write that I'm subtracting all of g. Here is something to be careful of. Make sure you put g in parentheses because you are subtracting the entirety of g. You are not just subtracting the first term, just that x squared. You are subtracting everything. So there's technically an invisible negative 1 right here. I'm going to distribute that negative 1 in so that I do not forget to subtract the entirety of the problem. Now, let's do some math. Let's combine some like terms. Negative 8x squared minus x squared is negative 9x squared. Positive 4x minus 4x, 0 plus 3. So f of h of x minus g of x is negative 9x squared plus 3. Let's try number 5. So they want me to do h of j of x. So I'm doing h of x minus 5, right? That's what I'm going to do. Every time I see an x, I'm going to write x minus 5. So I'm going to start writing out h. Oh, I see an x. I'm going to put x minus 5. Notice it's a squared. Minus 2, another x. So let's plug in x minus 5 again. Ooh, x minus 5 quantity squared. So x minus 5 to the second power. That's a little sidebar over here, okay? X minus 5 squared. We know being to be squared means to multiply by itself twice, right? So that would be x minus 5, x minus 5. I would recommend writing that out and then multiplying it through. So I'm going to FOIL here. I'm going to go x times x, negative 5x, negative 5x, positive 25. I'm going to get an answer of x squared minus 10x plus 25. A lot of students will write x squared plus 25. They'll distribute the squared. Do not do that. You have to write it twice, and you need to multiply it fully out. Do not miss that middle term. Otherwise, your composition will not be correct. So I know x minus 5 quantity squared is this value. So I'm going to rewrite that. Okay, I want to distribute my negative 2 in. Distribute my 4 in. There we go. Combine some like terms. Put some equal signs so it doesn't look like I'm terrible at it. There we go. That is my composition of h of j of x is 4x squared minus 42x plus 110. Let's try the last one. Notice there's something different about this function. You're right, it's equal to 0, okay? So there's a little bit of a step we're going to have to take after this. Let's first just find that composition, just like we've been doing. So we need to plug in negative 2x into h. So I'm going to write that out. Like that. Okay. Negative 2x quantity squared is 4x squared. We're going to have plus 4x right there. So this is 16x squared plus 4x, right? That is h of f of x. Now, they want that equal to 0, which means we are going to be able to get an answer of x equals numbers. So over here, I'm going to take my function composition answer that we just got, and I'm going to set it equal to 0. Now, since this is a quadratic, aka power of 2, I probably need to do some form of factoring possibly. So first thing I like to do is check, is there a common term between my two terms? Or a common factor? Which in this case, right, there is, right? There is a 4 and also an x. So I'm going to factor out a 4x. If I do that, I'll get 4x plus 1 left behind, right? Because if I redistributed my 4x, I should get back here. Now what's cool is I can set both of these pieces equal to 0. So I can set 4x equal to 0 and 4x plus 1 equal to 0. Let's solve. Dividing by 4, I will get x equals 0 for one of my answers. Subtract 1. Divide by 4. I will get x equals negative 1/4. Notice the difference between this problem and the last couple we've done. This one had x equals because it had an equal to 0 to start out with. And remember, when you want to factor, you always have to be equal to 0. And that is the end of this video. I know compositions take a little bit of time, and there's definitely a lot of algebra involved. So if you have any questions, definitely talk to me and I can assist you. Until I see you in class, I will see you later, Savers.